Alright, so over the last few lessons we've looked at various differentiation rules, specifically rules for doing the derivative of a sum, a difference, a product, and a quotient. But remember, there is a fifth way that you can create new functions out of basic functions, and that is through composition. So what we want to look at today is how to do the derivative of a composition of two functions, which remember means one function within another. So I've got a composed function here, y equals f of g of x. G of x is inside of f. And the chain rule says that the derivative of that is the derivative of the outside function multiplied by the derivative of the inside function. So f prime of u, where I'm calling g of x u, multiplied by the derivative of g. And another way that I can write that is dy dx is the product of the outside, dy with respect to u, times the inside, du with respect to x. And you can kind of think of the du's as canceling out to produce our dy dx. Alright, let's take a look at an example of this. The inside function I'm calling u. And I'm going to do this from various points of view. So the first one, I'm just going to jump in and apply the idea we just talked about. My outside function is something to the sixth. Well, we know from the power rule the derivative of that would be 6 u in this case to the fifth, okay, where u is that entire inside function, multiplied by the derivative of the inside function by itself. So the derivative of just this would be 6x plus 2, and there's my derivative. Alright, let's just approach this same question from a slightly different point of view. Again, I'm going to label the inside function u. And so I can think of this function as being made up of two functions, y equals u to the sixth, and u equals 3x squared plus 2x minus 1. And I'm going to do the derivative of each of these separately. So this is the derivative of y with respect to u, which is 6u to the fifth. This is the derivative of u with respect to x, which is 6x plus 2. And my chain rule is saying that the derivative of the entire function, of the composed function, is the derivative of the outside function multiplied by the derivative of the inside function. But since I want this all with respect to x, and since x and u were related as shown here, I can make the replacement back as follows. Alright, let's look at another example that's a little bit more complex because chain rule doesn't exist on its own. It's often applied with other differentiation rules. So here I have a function again, u to the 17th, and the inner function is the quotient of two functions. So what I'm going to have to do is apply my chain rule, but within the chain rule I'm going to have to apply the quotient rule. So the derivative is the derivative of the outside. So I think u to the 17th, my derivative is 17 times u to the 16 multiplied by the derivative of the inside. And this is going to be the derivative of my quotient. Okay, so I'm going to do the derivative of this entire part. And on the next line I'll actually work that out. So here we go. 17, 1 plus x squared over 1 minus x squared to the 16th. And here we go with the quotient rule, which remember is the bottom function multiplied by the derivative of the top, which is 2x, minus the top function times the derivative of the bottom, which is negative 2x, all over the bottom function squared. Okay, we can do a little bit of simplification here. We have this to the 16th and this to the second, which means on the bottom I'm going to have 1 minus x squared to the 18th. And on the top I'm going to have 17, 1 plus x squared to the 16th. And then I could multiply this out and simplify this. So I'm going to get 2x minus 2x cubed. I've got the two negatives canceling here. So it's going to be plus 2x plus 2x cubed. Isn't that nice? The x cubes cancel out. And so I'm left with a final derivative as follows.